Hello, and welcome to our webinar, Adopting AI, Ensuring Business Readiness. I'm Abby Lundberg. I'm a business technology researcher and writer, and president of Lundberg Media. I'll be moderating today's discussion. One way or another, artificial intelligence will be important to most organizations' futures. In part one of this series, we explored how to pick the right problems to solve with AI. In the second installment, we'll examine what it takes to launch an AI initiative from a business readiness standpoint. This includes making sure critical business enablers are in place, including a basic level of understanding of AI among users and appropriate oversight of AI initiatives and business processes. It also requires understanding and mitigating the inherent risks of AI. Our speakers today will discuss these issues and more. They'll help you determine if your organization is ready for AI, sharing their expertise across a range of industries, with a special deep dive into AI use cases and challenges in a sector that affects us all, healthcare. Kimberly Nevela will start things off. Kimberly is a strategic advisor at SAS and an expert in the areas of advanced analytics, information governance, and data-driven culture. She helps clients understand both the strategic value and the practical realities of artificial intelligence and digital transformation. Kimberly will be followed by Fernando Lucchini, Managing Director and Global Lead for Data Science and Machine Learning Engineering at Accenture Applied Intelligence. Fernando has spent more than 20 years creating technologies to automate and understand text, speech, and video data, and integrating these technologies into business solutions for Fortune 100 companies across a wide range of industries. Dr. Tad Funahashi will provide the practitioner's view. Tad is a practicing orthopedic surgeon and the Chief Innovation Officer for Kaiser Permanente, Southern California. He leads a team of physicians, consultants, designers, data scientists, and engineers who work together across Kaiser Permanente to envision and build the healthcare delivery system of the future. Welcome to you all, and Kimberly, I'll turn it over to you.
Thank you, Abby. All right. So I'm going to kick things off today by quickly reviewing 6 characteristics of AI algorithms that require us to apply additional business due diligence as we design, deploy, and maintain these systems in the world today. So the first, and you're probably well aware of this, is that AI algorithms are abstract. Unlike rules-based systems in which it's fairly easy to follow the logic to get from A to Z, the inner workings of AI algorithms can be almost incomprehensibly complex. And these are probabilistic systems, so their outputs are predictions, which are imprecise by nature. Now, techniques to be able to shine a light on the inner workings of AI algorithms, known as explainable AI, are rapidly evolving. But it's important to note that while these techniques can give us information about which factors most influence an algorithm's predictions, they cannot make the decision for us of whether those factors are in fact right, fair, or just. In addition, and this is important to know because AI systems are adaptive. They respond to changes in the data input they receive. In other words, they learn. And this is both the good news and the bad news. These solutions are very smart, but they are not creative. So if the behaviors or the environment change in unanticipated ways, the solution is not going to come up with a novel offering or response. It's going to revert to the best fitting previously known pattern. And this is why we saw so many analytics and AI models initially fail when COVID came on the scene. It's also important to note that AI systems are typically deployed at scale. And what this means is that small errors can quickly become magnified and in fact become self-reinforcing over time. If we don't have really good feedback loops that tell the algorithm when it's making the right choices and the wrong or a suboptimal choice, it is going to assume that the choices it makes are correct, and that will then inform its future choices, and so on and so forth. And you see where this leads. You can see this in your day-to-day life, in your social media feed, for instance, when they seem like they very quickly become hyper-focused on a single theme or topic. So it's important then, as we think about that, to know that these systems are also highly impressionable. And by what I mean by that is that they only know what they see. So the data that an algorithm is exposed to while it's in training and while it's in production is its entire worldview. It has no insight. It's completely blind to data or factors not reflected in that information. And it is really, really good at picking out sometimes just strange correlations or really thin correlations in that data, even if those correlations are spurious or they don't reflect our desired future state. And this is where we see things like hiring algorithms that become biased against women, even though gender isn't actually an explicit data field. Now, in addition to being impressionable, AI algorithms are a little like teenagers, and I don't want to anthropomorphize here, but they're incautious. They're going to make mistakes, but because they're not self-aware, again, they're not going to know unless we tell them. They also don't apply any level of independent discretion or tact. So it's critically important that we clearly define the operating conditions for these systems and then engineer robust safety controls and resiliency into these processes. And particularly, this is particularly important because AI is increasingly just interwoven into the fabric of our core business processes. And this means that it becomes increasingly difficult for us to always fully understand the downstream impacts and implications of these systems. It can also become easy, it is also easy to become over-reliant or overly trusting in the information being provided. So if your self-parking car has never made a mistake, you let your guard down, even though it may make a mistake in the future. And as soon as you let your guard down, the engagement model that system was designed to operate in has changed. So ensuring that our users not only understand how an application is intended to be used, but also watching how they actually use it is mission critical to making sure that AI solutions deliver their intended outcomes. So there you go, 6 characteristics of AI systems that require increased business due diligence. Now, with that said, I want to turn things over to Fernando to talk about 6, I believe, best practices for ensuring your AI solutions are adopted and can be adopted at scale. Fernando.
Lovely, thank you very much for that. And I want to give you a perspective I'm part of Accenture, which of course is a service company. So we're great observers as we're having to deliver these things. We're also great observers. So let me give you my 6 lessons of what we see are good practices that people have when they do it, when they have that business readiness, right? But first, if somebody can move me to the first slide, you'd be so kind. We're going to top and tail with this particular slide. What I want you to tell you here, so you understand, is that when we think about AI, we have to think about everything that goes with it, from the beginning to the end of the journey. It never is just about the model. It never is just about the data. It's always about that journey all the way from idea to how you make this work in production. So keep that in mind. We'll come back to this, but I just want you to, and you'll have this slide later so you can do your own mental modeling, but it's important to think of it as a complete problem. Otherwise, business readiness becomes incomplete. Thank you, Kimberly. So for the first, I want to give you a couple of bits of data from our latest research. We've done research for around 1,500 companies, C-level executives, asking them about AI and their business readiness. And a couple of things stood out for me. First of all, you see there's some interesting things. That 84% of the executives that we interviewed believe that they wouldn't achieve their growth objectives unless they scale AI. Okay, this was not a leading question, so it's interesting that it comes like that. Second fact, that 76% thought they would struggle to scale. Okay, so I need to scale to be successful, but I'm going to struggle to scale. Okay, that's interesting. And the last one, which is the 75% believed they would be risking going out of business if they didn't get the value. By the way, to me, this tells me a bunch of things as a practitioner and as a chief data scientist, which is that there's a high level of work we have to do in educating our executives, because I mean, this is the numbers are almost like scare level numbers. And the other, there's a lot of work to do across the organization so they understand, how do we get to this value. But I thought it was interesting for you to see this. And if Kimberly, you can move me to the next. Second interesting piece that came out of this research, which I hope helps your thinking, is this: we could really clearly see these customers into three categories. The category of where most customers were, which is this first proof of concept factory category. And I've given you the characteristics of each there. And this is part of the research as opposed to just my point of view, where 80-85% were effectively not really seeing the value of the work in AI because it was stuck in the proof of concept, never achieving production. And there was a bunch of reasons why: the misalignment with CEO, not really, having a lot of labs, but not a lot of abilities to do the route to life, and so on and so forth. Interestingly, the second category was the strategic scalers, where it's only at 10-15%, where they had figured out, they had great connection of the strategy to the CEO, to what the people are actually delivering on the ground. They had a clear strategy of what was important per the first session in this series, where we talked about that, where they had the multidisciplinary teams, all the C's you said there. And finally, the third category, which was the industrial growers, very small amount. And for those folks, these guys were beyond readiness. These were now in real, fast mode, right? I always say AI is a little bit like building a car. You got to get the wheels on quick so you can do miles, right? So these guys had, the best car. They were rolling out. They had a lot of miles behind them. So I think the challenge for us in business readiness is that line in between the 85%, that category one, and that category two. So let's talk about these 5 lessons as they relate to this. First lesson is that the AI is affordable and easily accessible. This for me is by the way, in case you haven't read the book I quote there, is Dr. Kai-Fu Lee's book about China and AI in China. It's an incredible book. Please read it. But in the first few chapters, he describes very clearly that China is doing great in terms of using AI because they are using, not necessarily because they're doing fundamental research in AI, but because they are great users of the technology. And we'll talk about the moral and the other responsible type of positions later on this. But as it relates to this, and Kimberly, if you can move me to the next one, an example of this, for example, is this. This is a little fun thing from OpenAI and their product called GPT-3, which, in case you guys haven't played around with it, is effectively a great breakthrough in natural language processing. But the point is that it's something that you can use as an API. It's really readily available. It can interpret and understand text in ways that it can even do simple arithmetic. And those examples I put on the screen are real examples where I can ask it to a sequence 1, 3, 5, 7, and it will finish it, or the Fibonacci sequence 1, 1, 3, and so on, and it will finish it. So, and it will do this on the basis just of its understanding of text, pure text. So when in a world where we have all of these tools available, like GPT-3, like say, APIs for cognition, like there is no single data scientist in the world that builds or writes line by line a model for a regression anymore. They take it down from the internet, it is done. It's very important that to have business readiness, we have that muscle of use, and accessibility is important. Second one, thank you, Kimberly, is the definition and finding of value. People that are doing very well are very, very good at defining and finding value. And let me give you a couple of examples. Kimberly, if you move me to the first one, the next slide. The research tells us that the people that are doing great defining, so this, by the way, by defining and finding, I mean, what is it that we need to do? What's important? What's meaningful? What's going to change the strategy? What's going to be material to me executing the strategy of the company that happens to have AI in it as an accelerator? We found that the people that were doing it very well tended to have a great return. And the way I tend to use this as a rule of thumb that I want you to think of, if you move me to the next, Kimberly, is this idea of 10 times, not 10%. It's critical that as you approach problems in AI and you think about and on average, a bank may have 300, 400, 500 things that they are initiatives that they want to do that have AI in them. Telco companies might have 1,000. In that long list of strategic things we want to do where AI is a key part, let's think 10 times. What is the thing that's going to bring us 10 times value, 10 times saving, not a marginal benefit or a marginal saving? Why? Because very rarely do we see people actually approach problems little by little and actually get there. Given that there's so much technology available, it's almost better to take a problem that actually is more material and can actually be a real part of your strategy. And that in itself, if it washes its own face, as we say in the UK, if it has a good business case, it will bring all the value behind it. So 10 times, not 10%, keep that. Thank you, Kimberly. Yes, the next slide. So the next lesson is this scaling of value. So if we look at the first one, we know it's affordable and easily accessible. So let's get using. Number two, we exercise the muscle of defining what's valuable and making sure we're doing that. The third one is just do more of it. How do we do more of this? And this is a complicated one. If you move me to the next slide, Kimberly, thank you. There's many lessons here. I'm going to give you 2 or 3 because of the so you can have context. Number one is this idea of do the basics brilliantly. It's very, very rare that you can build a racing car, or you can build any kind of advanced technology without having the basics well, the wheels turning correctly, the brakes working, all these things that need to be true. So for AI to work very well and scale very well, you have to set yourself up with great data infrastructure, a great data science methodology that is geared towards getting you from the beginning to the end, a great route to life that allows you to take that project and make it into production, a great focus on the kind of technology that you need to scale certain things. So think of the basics. And within this same sphere, without moving from this slide, you also have to think about simple, really simple things. Sounds simple, but are quite complicated. But they are, in scaling wise, governance and other things that are outside the normal realms. Maybe they're not anymore, but outside the realms of doing this. So do the basics brilliantly, buy, build, borrow strategies. So all the kind of things that allow you to have a great business. So, and Kimberly, if you can move me to the next, please. So next lesson is this idea of people, capability, and culture, which sounds like the most obvious thing, right? But the truth is, if you move into the next one, the truth is we many times get this wrong. So what do we mean by this? We have to bring people along for the journey. AI is everybody's problem in a firm. So the firms that do very well tend to have the following characteristics. They tend to have the right talent mix. So I always joke that data scientists don't build products. Software engineers, behavioral engineers, all an entire family of people build products. So let's have that. Let's have those families of people doing our objectives, right? So look at how you're doing this in your organization. Make sure that the distance between the C-suite, so the people that are setting up the strategy for the company, and the people that are doing the work is a small distance. It's quite very well aligned. We see that as well. And I say my favorite, the reuse before buy before build. So don't try to build everything yourself. And if you look at some of the stats there, which were interesting, I'll give you one of the ones that I like, which is the idea of these employees that fully understand AI at scale. There's quite a large distance between the POC group and the scalers, right? If you can observe there, where the more we educate the firm about their role in the AI lifecycle, the more that we see that we become a strategic scaler, which is the place we want to be, because that's where we're actually getting things done and scaling them up. So people, capability, and culture. And the last one, which is this idea of proceed responsibly and build trust. I mean, this is an incredibly important topic. I'm sure other people in this room will agree. But what I want to, if you move me to the next one, just to introduce a few concepts, Kimberly, I think what's important is several things. That we have to create a responsibility framework that adapts to our company, our citizens, our society, and that we're very open and transparent about how this is. This is category 1. Let's make sure we're clear about what it is that we're going to do with this wonderful technology. Secondly, we have to put the technological aspects in place that allow us to have the guardrails to act safely. There's going to be a lot of people that are going to be working on AI in a single company or a single government. So to think that one individual or many working together are always going to get it right is not really fair. So we really have to think about the professionalization of AI and how that professionalization leads to building things responsibly. And by the way, by professionalization, I mean everybody's role understood, guardrails, methods, all of this, and technical implementations, which connect with some of the numbers you see there. I specifically like the 60% of respondents who reported that they still wanted to have a manual override. Of course you would. And again, we're not trying to make that number change. What we're trying to do with building responsibility is understand the role of everybody, so we can all be comfortable about whatever the number is, that it's actually doing the right thing for our company, our government, our citizenship, and the world at large. Which, Kimberly, if you move me to the last one, which funnily enough, as you can see, brings us back to the roadmap. So it becomes clear that as you're going through this roadmap, you're going from ideation to, do I have the value and the strategy? Do I have the right people? Am I setting up myself correctly in governance to do this? And am I actually then getting the value, realizing the value throughout this? These 5 lessons will fare you out, which is get using, make sure you're doing the valuable things, the things that matter. Make sure you're setting yourself up to do more of those things. Make sure your people are coming with you on the journey, and make sure you're watching for whether it's within the boundaries that you've set yourself up morally and ethically to continue that work. And then within that, I will give you the challenge before I hand over to Tad to take your own company and your own government through this framework. Go from start and see if you actually have today the ability to go uninterrupted to the end of that journey, and see where the journey is interrupted. Think about why that's interrupted and whether you can actually make that continuous to give you that scale. Kimberly, I think at this point I'm handing over to my friend Tad.
Well,
Over to you, Tad.
Kimberly, really great framework in terms of how to apply AI in the business sense. What I thought we would do today is to take some of those learnings that we've applied it to healthcare and share with you some of the lessons that we've learned. So next slide, please. So we'll touch a little bit about the use of AI and machine learning in the area of healthcare. We'll give you some clinical examples where we've applied it and the challenges that we found in that. And then some guide, which I think Kimberly and Fernando have done a really good job of already in terms of addressing the challenges as certainly it applies to healthcare. Next slide. So there's no doubt that there's a great deal of enthusiasm in the use of AI and machine learning in healthcare. For example, in our institution, we've collected electronic records for almost 2 decades, amounting to approximately 44 petabytes of healthcare data. Just to give you a relative scale of what that is, it would be roughly a physician that's been in practice for 170 to 180,000 years, with perfect recollection and near perfect pattern recognition. So if you could have such a doctor serving you or taking care of you, there would be a great advantage, right? So we want to unlock that capability. We should certainly be able to make diagnosis better, make better predictions, treat illnesses more precisely, and really be a much more personalized type of care that we could deliver for you if we could really unlock that data. And we're also beginning to look at data and the uses of machine learning and AI in wearables. Next slide. So the main areas that we're really looking at the applications of AI in healthcare in our institution currently is one, in predictive analytics. With all of this experience in terms of what's happened thus far, we can tap into that and guess what might happen again in the future. So looking at things like who's most likely to progress in a disease, who is most likely to be readmitted after a hospitalization, or for that matter, who is most likely to be admitted even if they haven't been admitted before. Because I think very few of you out there think to yourselves, I have a week off next week. I think I'll go to the hospital, right? So if we could prevent you from having to go to the hospital, it is something that we believe is much more of a desired outcome for all of our members. Personalization and risk stratification is a key part of our use of data. And Dr. Permanente is well known for preventative care. And when we do preventative care thus far, you could say that we've used crude instruments such as gender, age, ethnicity, and whatnot to try to look at people that are higher risk for certain diseases. But if you could leverage that data and really tailor the prevention for even a tighter group, you can really focus on those groups and really have much better health outcomes. Now, a lot of our health records are, as you might imagine, locked up in our unstructured data, that is in the notes of doctors, in the notes of nurses and whatnot. And there's always been this long joke about doctors writing when it used to not be electronic, that nobody could read that writing, right? Very hard to unlock. Well, even in the computer, if it's unstructured, we need natural language processing and whatnot to really extract that information out of there. And we're really beginning to develop some advanced NLP technologies to be able to really unlock the value in the critical knowledge that's locked in the unstructured portions of our electronic records. And finally, I think all of you have heard about image recognition used in health, such as retinal imaging, dermatologic imaging, pathology imaging, and in radiology imaging. And we are also looking at all of those areas. Next slide. So first, we need to talk a little bit about the technical challenges, so to speak, of doing modeling or AI, machine learning, and health. And I think some of these were covered previously very well by our previous speakers: interpretability or explainability, bias, outlier edge cases, and drift. Let's look a little bit more carefully at each one of these. Next slide. So in terms of interpretability, doctors and healthcare workers are famous for not believing almost anything that's said to them, right? So there's a new study that comes out, and it's a definitive, randomized, double-blinded study, and they go, let me look at that to see if it's really right. And in fact, that's one of the reasons that any kind of new discovery in healthcare takes about 17 years before it becomes the norm. Well, imagine if you gave somebody a blinding insight about what's about to happen, but it came out of a black box. Would doctors really believe it? Well, the answer is no. So we have to figure out a way to make the data that comes out a little bit more interpretable. And sometimes, interestingly, rather than creating tremendously complex models, we sometimes want to simplify the models so it's a little bit more explainable and interpretable to the physicians. Now, bias is something that's innate in healthcare, right? Most bias can be good, but some bias can be bad. That is, we know that certain populations that are higher risk, that is innate bias in the statistics, right? But if the bias is nefarious, meaning that it doesn't improve the outcome of those people, then it's a negative type of bias. And it could be anything from ethnic groups to social economic groups and whatnot. We need to carefully analyze that to make sure that the historic practices of the past that had innate biases that we didn't detect aren't replicated in the future. Outlier cases, in fact, are the ones that we stay up at night. The reason you want to come see a doctor instead of Dr. Google is that most of the time, you're going to be fine with whatever it is that's common. However, there are certain cases that are atypical, the red herrings. And when everybody is in my office and I'm examining them, I'm looking not only at what they most likely have, but what they could possibly have. And unfortunately, right now, AI is not that good at detecting those. It's more of a statistical norm rather than looking for outliers. And as you know, healthcare practice changes over the course of time. We don't practice the way we did 100 years ago, 50 years ago, or for that matter, even 5, 10 years ago. But remember, AI looks at the empiric data that's available from our past medical records and replicates them. I think Kimberly talked about this earlier. And so as practice begins to drift, we need to make sure that our recommendations that come out of the AI systems are also updated and continuously improved. Next slide. Now, my data scientist and engineer tells me all those problems that I just talked about are the easy part. The hard part, in actuality, is in the implementation and execution. That is clinical validation, workflow integration, privacy, data governance, and IP, and the decision as to whether to build or buy to create these. Let's take a little bit deeper look at these. In terms of clinical validation, we need to make sure that the data scientists and the doctors work hand in hand closely so that the predictions that the machine is making, in fact, make sense, number one. And number two, that it's accurate, right? So that it's not making wrong predictions. And then ultimately in that process, so that the physicians begin to develop a trust in that data that's coming. Ultimately, AI, or artificial intelligence in healthcare, will most likely become augmented intelligence. That is a pinging of things that we should be thinking about, or broadening our diagnoses in clinical arena that AI can help us do. Perhaps one of the most important is workflow integration. If the data isn't given to us timely, if the data isn't relevant, if it's not actionable or interpretable, and we don't trust the data, and it's not a part of our decision-making process that we typically do in taking care of our patients, all the fancy arithmetic and the predictions are not that helpful. So we need to make sure that the predictions of the model are presented to the physicians in a usable manner that's timely, that's meaningful. It goes without saying that healthcare information is incredibly sensitive, so privacy issues are critical for us. If we ever do share data with external companies, and this will get into the build or buy, that protection of that data? What happens to the data after it leaves, so to speak, our walls? The governance of that data, and ultimately even the intellectual property that's associated with it, can really be challenges in terms of how best to utilize that data, because sometimes there's great engineering resources outside, so to speak, our walls of Kaiser Permanente, and yet how do we leverage that expertise without putting any of the privacy or ownership issues at risk? In terms of build or buy, there are models that are built for a variety of hospital systems or healthcare systems, and yet geography, financial incentives, variety of other things can have slightly different impact on the data. And so that data and the models that are built on that are not necessarily directly transferable. So we need to pay attention to that. And yet, if you say we want to make sure that we build it that's customized for our database, it requires tremendous CPU, GPU, engineers, time, and it can be extremely expensive to build, and then obviously to continue to keep it updated. So that's another area that we need to keep attention to. Next slide. And so as we really begin to think about the application of AI or augmented intelligence for healthcare and machine learning, it really is only one part of the creation towards increased operational efficiency and quality that we look at in healthcare. And so it's a tool that can be potentially helpful, but an amazingly accurate tool that's 99% accurate isn't really that helpful if we don't have timely access to the data, if there are no clinical interventions that make any difference. You can have if you know it's going to rain, but you don't have an umbrella, right? That doesn't really help you, right? Same thing in healthcare. If you know something's going to happen, but there's nothing we can do about it, it can be sometimes frustrating. It needs to make sure that when we do get the data insights, that there's supporting processes and workflows that allow that intervention to happen. We need to make sure that there are trained resources to make that happen, and that there's appropriate infrastructure for not only scaling it, but also in terms of making sure that the model is interoperable across our entire enterprise. And of course, after we do that, we want to make sure we have metrics that look at both the performance of it, from making sure that there's no bias, that the quality is there, in fact, it has good impact on our costs, and ultimately that it's serving our members in a much more efficient manner. The next slide. So if we were to put this all together, we kind of take a stepwise approach to that. So as we look at applying AI or any large models like this, first, we want to make sure that we're not doing it just because it's fun, but it's actually solving a specific clinical problem that we typically couldn't solve as well, or could begin, like Fernando said, really creating a different type of model for healthcare. And once we do that, we want to make sure that the engineers and the physicians work side by side all along, that the physicians have faith in what the engineers and the models are outputting, and that the engineers truly understand what they're solving for. Of course, since we get so much data, we need to make sure that the data quality is good, that we adjudicate data that may be coming from slightly different sources, that the quality of the data is at the highest level that it can be. And then once we build that model, and 1, 2, 3 are all about the model building, that the outputs are objective, right? And that unwanted bias is not programmed into that model. And then in the lower 3, 4, 5, and 6, really about execution, we need to make sure that once we do put that in there, that there is value in terms of quality outcomes, service outcomes, cost, whatever it might be, that it is in fact something that is of value to the organization. And as we roll out these things, we need to make sure that its performance, even though it may have been good to begin with, isn't beginning to decay over the course of time. And I think the last goes without saying, and certainly in healthcare, regulatory requirements and oversight of all of these models are absolutely essential to make sure that we are compliant. So with that, let me now turn it back over to Kimberly and Abby, I believe, who's going to jump us into the Q&A section of this. Thank you, everybody, for your attention, and look forward to a discussion.
Great, thank you. Thank you for those great presentations, really useful information. And we do have some great questions coming in from the audience. And we will continue to take your questions for the remainder of the hour, so you can keep submitting those. To kick things off, so we've got questions on around a couple of different areas, and I wanted to start with sort of the sort of state of AI right now. And so this question was, how mature are AI solutions now? Can you find one for any application? And how much are customization or tailored solutions required? So, can you go out and just buy something for a problem that you're trying to solve, or how much do you really need to be customizing and doing your own work on that, or hiring somebody to do your work on that? And I guess that's a question for all of you. Kimberly, you want to start?
Yeah, absolutely. And I think Fernando probably has some good experience in this area as well. I think that in a lot of ways, AI has become very ubiquitous in that a lot of the solutions that we are solutions we buy off the shelf today, in a lot of cases, may have these advanced analytic capabilities built into them. But as Tad said, I think in a lot of cases, what you're looking to do is to buy some of the core capabilities, whether that is computer vision capabilities, natural language processing, and then customize those to the specific use case that is there. So today, I think the build versus buy, there's probably still a lot more customization that happens, even when we're buying a solution that's packaged with artificial intelligence. It's really important in those cases that you ensure that the environment and the operating, whether that's sort of the way it interacts with your customers or your consumers, your users, the operating environment that you are deploying that solution in actually matches the environment it was trained in, i.e. that it reflects the data that it was trained on. And there's really no sort of fast track through that part of the process, I don't believe. But in a lot of cases, I think most organizations find that especially around core business processes, whether that's in sales or customer experience in some of these areas, there are packaged solutions that you can begin with, validate and customize to your needs. That being said, there are also a lot of off-the-shelf now packages around that are the data science packages. So you can get the math, if you will. You can find organizations that these algorithms that come out of the box that you can then apply to your data that come packaged with interpretability and explainability in some of these components. The trick again is really matching those solutions so that you're finding sort of the right problem with the sort of right hammer. And that's probably the bigger issue right now. Not so much finding an available tool, but making sure that the tools that are available actually match the problem you're trying to solve. Fernando, your thoughts?
Yeah, a slightly different perspective, which is that if you think about it today, if you're a startup and you don't do some AI, you're probably not going to get any money. So there's tools for anything you can think of. There's AIs or AIs for most of what you do. I do a little test that may make you smile, which is to think about from the moment you wake up to the moment you go to sleep, write down where you feel AI has been part of your life. If you know a little bit about AI, I mean, it's my world. The list is enormous. It's enormous. You give it to my mom and it's nothing, obviously. So our perception of this. So what I will tell you is there's tools for everything. There's things that you can use really easily, but doing what Tad has described is mega difficult. So there's a lot of things available, but it doesn't mean you're actually going to get what you need. It's almost an excess of stuff. But still, the people that do very well still tend to be super advanced in putting it, which is what you're saying, Kimberly, putting it together and making sure it serves a purpose and in the context of a company and in the context of all these other things. So, and that's why I have that first lesson, which is availability. I mean, it's there. Doesn't mean it's easy, right? But they're absolutely, totally present.
Yeah, I would agree. I think the number of tools that are available in the area of AI is, I would make it akin to an auto shop or a Home Depot, right? There's tons of tools out there, and you can build just about anything with all the tools that are out there. In fact, we do leverage many of those tools. At the end of the day, though, you have to build those tools to build something that you need that's unique to your particular business, right? And in order to do that, just having a collection of tools doesn't do it. You have to put it all together. And not only after you put it all together, you have to have somebody that's willing to drive it, so to speak, right? The end user, so that not only are the tools important, the user interface and the method by which the output of those tools are given to the end user is really critical, right? So if you think about driving a car, if we didn't have those simple tools that allowed you to steer and accelerate and brake, a car could be incredibly hard to drive. And if it's incredibly hard to drive, people aren't going to use it, right? And if you think about it, though, all of the components of that car are incredibly complex. In fact, many of them do leverage AI now. And I think it's not that dissimilar in most industry, and certainly not dissimilar in healthcare.
Great, thanks. We've got a lot of questions coming in that are very appropriately, because we're talking about business readiness. These questions are around the people part of doing AI. So the first one is, who should be on the AI team? Who do you need on your AI team? And Tad, if you want to start on that one, that would be great.
Yeah, sure. So first of all, the basics, right? You need the people that understand the computer, the engineers, the data scientists. And those are just table stakes. Without that, there is no data science, right? Having said that, though, them in a vacuum doesn't do it for us. We actually need the end users for a variety of reasons. Number one, we need to understand exactly what their problem is and what type of solutions would best help their problem, right? So we need the end users. Sometimes, though, the interpretation of that by engineers lacks a step, so to speak. So human-centered design people are really critical, not only to, so to speak, translate what the end users are saying that they need, but also to create the interface back from the engineers to those users so it becomes very understandable, right? And interestingly, we also keep in our team, of course, both consultants that can manage the project, but also classic epidemiologists and statisticians that can begin to bridge that gap, for lack of a better word, between traditional statistics that we are very comfortable with and machine learning, so that physicians begin to understand what's really happening. And even with that, the interpretability or the explainability can be difficult. But without it, that trust in what's happened can be lacking. So certainly in our field, that's also another critical component.
Fernando, you talked about the importance of, I think your slide was people, capabilities, and culture. And you talked about so when you think about that culture piece, I was really thinking about the fact that, changing culture takes time, right? And you also talked about the importance of moving quickly when you're moving forward with AI. So how do you balance the importance of moving quickly with the fact that culture does take time to change? Like where do you put your focus to sort of get past that dynamic?
Yeah, the simple answer for me is education. It's one of those moments where, and by the way, COVID has an interesting effect on this, which is that before COVID, many CEOs were thinking, oh my God, where's all this money that I spent on AI that doesn't seem to have produced any value? And suddenly COVID hits, and it's been an acceleration through survival for many that needed it. And I'm sure, Tad, you've seen a lot of this in the healthcare industry. So AI has become an accelerator to that culture point because it was survival. I don't know if it's going to continue to burn this bright and help push the. Obviously, we want this pandemic to go away, thank you. But apart from that, is it going to have a tail that continues to help us with this culture? Abby, we have the same problem with data. In that we talk about data-driven culture, and the truth is data-driven culture is a culture of self-service, of I can serve myself, I can do things, I am a creator of data and a user of data. AI is a bit more complicated because you don't wake up in the morning and decide you're going to create a neural net and you figure out the mathematics of that. But if you follow Tad's great way of putting it, you can learn what your role is in it. So I think education across the widest possible base of companies and government on the possibilities of AI, not just the use cases, but a real notional understanding of what it is. You don't have to understand the mathematics, but the notions will help remove the humanizing view that we have of this technology, of these machines, and help us with, I understand more or less how these things kind of work, so I can understand why this is going to work in a particular way. And I get this notional view of this, and that really helps accelerate these things. But that education, if you look at the winners, the people that do really well, it's all education. It's 100% education. And I can give you a fun way to think about this. The people we don't talk about a lot, which is if you put 5 data scientists in a room for 3 hours and you come back, they've done 5 models in 5 different machines in 5 different languages. They will never work together. If you put 5 software engineers, you come back 3 hours later, there'll be no code written, but they'll have worked out how to work together. They would have worked out how to share. Everything will be sorted. There's a set of people called ML engineers who are the performance and scaling engineering of models, who today are probably, if I can throw my hat out to that career, is probably the people that we need the most today to make that translation. They're the people that are going to take those 2 rooms and remove the partitions so they can be together. And we need a lot of those.
So it sounds like the last people you talked about, those are people that you need to have on your team inside the company. But there's other roles that maybe you've got to go out and get that have particular expertise around the data science and the real technical parts of doing AI. So this question is from someone in the audience. The question is, where do you find the people to create AI solutions? And they're thinking in terms of, companies, countries, the talent marketplaces. Where should people go to look to get that AI talent? Kimberly, you're on mute.
So let me start again. That I'll start and then I'll defer to Fernando and Tad. So one of the things I think that is becoming increasingly interesting is partnerships between industry and academia. And that could be whether you're utilizing, for instance, working with folks that are in college programs and even PhD and advanced programs to come in and work on your projects as part of their educational bit. At the end of last year, I had hosted a panel with the head of basically machine learning, AI engineering and deployment for Uber. And one of the things that they did that was really, really interesting is they essentially have a process by which folks who are actively pursuing the research aspect, which is really important in academia, are part-time working also for Uber and looking at the operational application of these components and balancing that sort of bit. You're getting this intersection of industry expertise and business acumen, so how this works in the real world, and not sucking away all the talent from the R&D side and that sort of basic science and research that's also required. And I think more and more we're going to start to see those kinds of, maybe not in that way, but those kinds of interactions and partnerships between things like academia, some of the research organizations, and commercial organizations as well. So I think that's one area to look at. I also don't think we don't underestimate the people who are interested and willing within your organization today to actually be trained up and to come into these areas to work. I spoke with Michael Kanan, who was chair of AI for the Air Force, and they did actually an internal survey and realized that they had a lot of folks that were engineers and not necessarily computer engineers, but had a lot of the skills and talents and interest in this area. And so being able to make them available and training internally available really resulted in dividends for them in terms of being able to build a skilled workforce over time. So those are some maybe not traditional ways of thinking about how do we develop and build or buy what can be very scarce and expensive resources.
I would just jump in. Really good comments, Kimberly, and to help the questioner look for that talent. Don't underestimate the talent that you actually have in your own organization. Data is a very interesting resource, right? And you actually need a data maven in your organization that truly understands the where, the context, and the availability of the data. You can have the most advanced software and data science in the world come into your organization, and we've certainly done that, right? And they said, okay, we would say, okay, go ahead and tap into our 44 petabytes of data, but they don't know the context of data, the availability of that, the adjudication of the data, the quality of the data, all of that. So you need somebody in your company that really understands that to really leverage the data well. And then on the flip side, or the way on the other side, you also need people that understand the power of the data and its applicability in your organization. Those two sources will come from within your organization. And then, so to speak, the tool makers, right? The people that really understand the building of the model. You can either hire that in-house or, as Kimberly said, I'm sure Fernando will say, you can outsource that. But they have to be people that can communicate well with your data mavens, the people that really understand it, and the end users. Otherwise, you have this disaggregated team that does not create for you anything that's particularly effective for your organization.
Can I quickly come in on that, Abby? Is that all right?
Yeah,
Because I've got a slightly different.
before you do, I just wanted to ask Tad if you could mute your microphone when you're not speaking. We're getting a little bit of feedback. Go ahead, Fernando.
Thanks, Abby. So this one's really interesting for me. So we talk in Accenture about making unicorns, not finding unicorns. But the reason we do is because we've done a study and a thought process of what is the future of data science. So where is data science going to be in 3 years? Not for everybody, for us, as it relates to us, very inward. And the truth is, what came out of that was that if you think 3 years in the future, it's very unlikely that the world is going to be full of generic data scientists. And remember, data scientist is a profession. It's a profession like Dr. Tad, right? Is a doctor. This is it's a profession. You don't wake up in the morning and decide you're a data scientist. So the best thing we can do is create those careers in companies, so you can be proud of having a career track which creates you these wonderful people that makes your industry problem. And and actually, to be honest, Tad, teaching hospitals are like the best example in the world of this. I mean, there's no better example. So you almost need like your teaching hospital of AI within firms to create careers for people, and that's what's going to set you up. Because if in 3 years we think we're just going to be able to pick these unicorns that understand my industry and understand this, and we're going to be in big trouble. So if I were to give anybody advice, is, and I did this for a bunch of CEOs in the last few weeks, is create a career. Create careers. If you create careers, you're winning. Then you don't need anybody. You don't need me. You don't need anybody. You just need to create that career.
Yeah, and I'll extend that a little further. One of the things that we talk about, and I think whether you're building these sort of internal curricula and career paths, or borrowing and leveraging external, we talk a lot about STEM, so science, technology, engineering, math, absolutely critical and core to what we're talking about here. But you're also now starting to hear people talk about, I think the new acronym I've seen is SHAPE, which is about sociology, humanities, ethics, sustainability. So somewhat the softer side of this, which is actually the harder piece of this in terms of adoption, really thinking more critically about how people want to interact with the solutions, what the impact of these solutions are, not just on users in terms of how they work and how it impacts our jobs, but also on the populations they're being applied to. I think, Tad, you spoke to some examples of this in healthcare, where we really have to make sure that it's not just the users that understand the solution and are bought into how it's being applied, but also the populations we're using it on and hopefully for and not against. And so as you look to develop these curricula and these skills, make sure that you're not just building these bastions of STEM that don't also incorporate and develop those skills associated with SHAPE, or however you want to call that out.
We have time for one or two more quick questions. This one is a little bit different. When you're thinking about business readiness, what do organizations have to do to understand and comply with the international, regional, and national regulations and regulatory bodies regarding the use of AI?
I can have a go if you want.
Yeah, please.
I'm sure Kim. It's an interesting one, because every company I know has a body that actually reads and understands the regulations for them, and every single one of those departments will tell you that nobody seems to really pay attention in depth to those. So GDPR is a wonderful example. If you think in Europe about protecting your data even further because of AI, and you think, oh my God, have you read GDPR? There's no chance that we're going to misuse data. No chance. No chance. Not possible. So my suggestion is please look at inside your company. You'll find somebody who cares deeply about how to use technology like this. Otherwise, the regulators around the world are doing a good job of trying to explain what their position is, even if their position is very young and very still thinking and still moving. Go and look. It's very easy to find, even on Google, the regulators' pages for how they believe AI should be used. So either look inward and you'll get great advice, or look to the regulator. They'll have great advice as well.
Yeah, and some of this is, a lot of the regulations today, Fernando referenced GDPR, which has provisions that then also apply to AI, or what they call automated decision systems and automated systems. There are a lot of emerging regulations. So there's a lot of principles today. There's a lot of fundamental, foundational statements now about what we want to do. There aren't necessarily, outside of what have been traditional legal regulatory concerns around things like data privacy and security that are specific to AI, but they are coming. So the other thing to be aware of here is don't assume. You have to start looking forward a little bit and try to start to project and predict a bit of where this is going to go and build these things in advance. Some of the new EU regulations, for instance, will require companies that are using AI-driven systems or AI-enabled systems to actually audit those systems and perform some assessment and due diligence of potential harms, for instance, and to inventory and make that inventory available. None of these are set in stone today, but having folks, as Fernando said, that are passionate about it, working in that space today, whether it's in compliance or ethics or legal, but also starting to look forward and plan proactively will be very, very important. And understand that a lot of times legal and regulatory compliance tends to come after harm has been done or ill has occurred. And so hopefully we can learn some lessons here and start to get, as organizations, in front of that, with or without the mandate of regulation, which I think is required and is coming.
Tad, yes, Tad, I'm going to throw this one to you. What would be what is a good practice to assess and monitor data science maturity in your organization? I assume that's something that keeps changing. And do you have a process in place for sort of making sure that the things that you're trying to do, you have that maturity to be able to accomplish what you're trying to do?
Well, first, let me take myself off mute. Wow, that is a really complicated question, right? Not easily answered, but working backwards, I think we said in our presentation, you want to make sure that the solutions that are being built have some pragmatic and real-world measurable outcomes and improvement, right? Otherwise, it's all an academic exercise, right? So we do look at to make sure that any application thereof has actually had a positive impact on quality, on patient service, cost, provider sustainability. Provider sustainability is a significant issue for us right now, especially having coming out of the COVID surge, which really put a great strain on our providers. So we do look at those as key metrics for any type of, not only AI, but almost any type of process that we put into place. Now, of course, understanding, so to speak, the capability of that data scientist to build the models that we're looking for is also important, but assuming that we hire the right people with the right qualifications, right? The other part that's really key is for that data scientist to be able, in the healthcare environment, to truly understand the needs of the end users in terms of physicians, and we put them in front of physicians and physician groups, as you saw earlier. And if they can't communicate, the most brilliant data scientist or the engineer that can build amazing things for you, but doesn't understand the needs or the language of the clinicians that they're building these tools for, are not going to be as effective. So just in brief, a couple of key things that we look at. Obviously, there's a multitude of other metrics that we need to look at, but I would say those are some of the key things.
Great, and I wish we had time to get that answer from everybody, but we are just about out of time. So thank you, Kimberly, Fernando, and Tad, for this really interesting and useful talk, and thank you in the audience for your great questions. I wish we had time for more of them. And a final thank you to SAS for sponsoring this webinar. We hope you'll all join us for the next in the series, which is on April 22nd, where we'll cover how to ensure the technical readiness of your organization for AI. Thank you so much.